Okay, everyone, good afternoon this afternoon to you all. I'm sorry for the late coming to this session. Today's class, I'm expecting us to start with a fresh topics. Now, previously we've done statistics and probability, and I'm very much sure that I have touched some areas that are very, very important when it comes to post-UTME examination. Now, I just want you to have an idea that there are some areas that I didn't touch, owing to the fact that they requires complex formula in solving. Now, areas like variance in statistics and standard deviation in statistics, I will want you to look for the formula on your own. Get familiar with the formula and solve one or two questions so that you can be familiar with how questions are set on variance and statistics. But I'm telling you, don't expect much questions on those two topics I'm saying. So I just want you to have idea of those parts. Now, for today's section, I'll be starting with a fresh topic called set theory. Now, set theory, you might not see question on set theory due to the fact that you'll be expecting questions on Venn diagram. That's the graphical representation of set theory. But expect the theoretical aspect of set theory, where you'll be given question in the theory aspect and you'll be asked to solve for intersection, the union, or any other terms used in set theory. Now, let's introduce ourselves to the topic we have today, set theory. Now, as we all know that this is a topic that we are well familiar with, set theory, we define set as the collection of group of things. Now, I'm using a layman language. We define set as a collection of group of things. Whenever you collect a certain group of things, that collection is called set. Now, the theory behind that collection is why we term this topic as set theory, because we have some rules and guidelines that guide every collection or group of things that are being placed in group. Now, in set theory, we have different type of sets. Now, we have subsets. When you say something is a subset, that means if A is a subset of B, then that means A is contained in B. Now, when they say something is a superset, it says A is contained in B. Then that means A is a superset says what? Every element of B is contained in A. And every element of A is contained in B. Now, if I want to use this same two sets A and B, we have set A and we have set B. If I want to use this set A and B to explain subset and superset, then I will say that what? A is a subset of B and B is a superset of A. Now, I repeat, A is a subset of B and B is a superset of A. That is just the two scenarios or the relationship between subset and superset. A is a subset of B and B is a superset of A. That is, every element of A can be found in B, but not every element of B can be found in A. That's just the relationship. Now, we are done with that part. Now, we also have some sets that you need to be aware of. Set like finite set, that is, elements of that set are countable. Now, what are elements? Now, we say this is set. A set A is a set of all even number 2, 4, 6, 8 up to the end. Now, if set A is a set of all even number, then A is the set we are talking about, and each and every even number 2, 4, 6, 8, yeah, are what? The element. So I say this is the set and these are the elements. So you should be aware of the difference. This is a set, these are the elements. Now, the type of set that I was talking about, we have the finite set. The finite set is a set where every element are countable. A, B, C, D is a finite set. Now, we have an infinite set. Infinite set is a set where every element in that set is uncountable. A, B, C with a infinity sign says, okay, let me use 1, 2, 3. 1, 2, 3. 1, 2, 3 up to the end is an infinite set because you don't know the ending of your numerical value. We also have another set of sets. We have the null set, which is an empty set, always empty. We also have another one, which is a singleton set, which is just a one set, a set with one element. We also have what other side of set we have? We have equal set. When we say equal set, now equal set is a set of two scenarios. When we have two sets A and B, A is having A, B, C, D, and we have B is having B, C, A, D. These two sets are equal because each and every element in A and B are the same, irrespective of the arrangement. These two sets, A and B, are equal because each and every element in A and B are the same, irrespective of the arrangement. Now, equivalent set says that set A and B are equivalent because the number of elements in set A is the same as the number of elements in set B. Equivalent set says that A and B are equal or equivalent because the number of elements in set A is the same as the number of elements in set B. Now, of that also. Now, I shouldn't be spending more time on all this type of set, but I just have to let you know that this type of set, you need to be aware of them. Should in case question comes on any of the type of set. Now, we are moving down to operation in set. Now, operation in set. Operation in set are the common operations that you'll be getting familiar with when it comes to exam. We have operations like union of a set. Union of a set says that what? All values or all elements of both sets. We have intersection of a set. Intersection of a set says common element from both sets. Now, we have the prime of a set says that what? Element that doesn't belong to a set are prime of a set. Now, we have power of a set. Power of a set says that what? These are power of a set that what? Let me say there's a term I want to use there because okay, the list of all possible elements, list of all possible subsets of a set. Yeah, that is power of a set. List of all possible subsets of a set. Now, there is one that they don't talk about, but I will put it there. Difference of a set. Difference of a set says that what? You are isolating a set from another. A set from another. Now, these are the operators you'll be working with when it comes to set theory. Now, also, I am supposed to introduce you to Venn diagram. Yes, I will introduce you to Venn diagram because it's a graphical representation of what we are doing here. Now, the Venn diagram is just the graphical representation of all this we have here.
Sorry,
now,
sir.
Yes, I'm here.
Please, sir, what of complement of a set?
The complement of the set is the one I term as prime of a set.
Okay, sir. Okay,
Yes,
sir.
set is the prime of a set. Can I proceed?
Yes, sir.
All right. Now, coming back to Venn diagram. Venn diagram shows the graphical representation of set theory. Now, let's say we have, this is the universal set that takes all type of set we have. So we have a set A and we have a set B. Set A and a set B, universal set. Now, when they say you find the union of A and B, then this shaded part is your answer. Anything that falls inside this shaded part is your answer for union of a set. I hope I've made myself clear. Anything that falls into the shaded part is the union of a set. Now, I
Sir.
move on to the next one. Intersection of a set. Intersection of a set says that intersection of A and B falls in here. Anything that falls into the shaded part here is called an intersection of set. Intersection of set. Intersection of set. A intersection B. Now, the next one is the complement. The complement of a set. Here, I'll be using one element. One element A. So I have A. Anything that falls outside here is called the intersection. So I can say A complement or A prime. This is the complement of a set or prime of a set. Complement of a set or prime of a set. And when it comes to two elements and you are looking for the complement, this is how it also look like. This is how it look like. Two elements and you're looking for the complement, A and B. You are looking for the complement of A and B. Then it is the shaded part outside here. So how do you write this? Using set notation, it is A union B or complement. Because this unshaded part is the union of A and B. And the outside is the complement of the union. So this is the answer to the Venn diagram on the board. Now, we have one other one, which is the difference. Yes, I told you that I will show you what the difference is. Now, if you are looking for the difference of A and B, if I say A minus B, it means you are giving me the answer for A only. Now, if I give you for B minus A, B minus A says that you are giving me the answer for B only. I hope I've made myself clear. I hope I've made myself clear. Now,
Excuse me, Yes,
when
sir.
Sir,
yeah,
that minus stands for what?
that what?
Minus. You said A
The
minus B. The minus.
symmetric difference. Symmetric difference. Is that clear?
Okay. Yes, sir.
Symmetric difference. They call it difference in set. So the difference of A from B or difference of B from A is the minus. So when you see the minus, it's telling you that what you are looking for the difference. So that means A only. Is that clear?
Yes, sir. Thank you, sir.
Okay. Let me introduce you to how you can solve questions on power of a set. Now, provided you have set A equals to A, B, C. Let's use A, B, C for instance. And we are looking for power of set A. Power of set A is having a formula. So power of a set is having a formula 2 raised to power n. Now, where n equals to the number of elements, number of elements, number of elements. N equals to the number of elements. So since we are looking for the power of set A, we can say power of set A equals to 2 raised to power. How many elements do we have here? We have just 3. So we have 2 raised to power 3 is 8. Now, if they now ask you to list out the possible element of the power of a set, that is why I said power of a set is listing out the possible element of a set. Now, possible elements that falls under power of a set are the elements that you can form using set A. What are those elements? You can form an empty set, 1. You can form a set A, 2. That's set with element A, set with element B, set with element C. You can form set with element AB. You can form set with element AC. You can form set with element BC. And you can also form set with element ABC. If you count the number of elements under power of a set, then you have it to be 8. So we start 1, 2, 3, 4, 5, 6, 7, and 8. That completes to be what? 8. I hope I've made myself clear concerning power of a set, please.
Sir, please, I
Yes,
don't understand.
sir, I
You
don't
don't,
understand.
I don't understand.
you see the same power of a set I'm solving?
Yes, yes.
Yes,
Okay.
sir.
This is the formula guiding it. Take note of this formula. Whenever you are told to find power of a set, it is 2 raised to power n. Are we together?
Yes,
Yes,
Are we
sir.
sir.
together?
Yes, sir.
Now,
Yes, sir.
since it's 2 raised to power n, so irrespective of the elements or the set given to you, you count the number of elements present in that set. I have just completed for set with element 3. Are we there? Now, let me just show you for set with elements of 4. Then you will understand it proper. So I extend this man. I change the elements here to be P, I, S. Now, those are the elements of my new set B. Are we together? So the element of my new set B, we need the power of set B now. So we say power of set B equals to 2 raised to power n, where n equals to number of elements. And number of elements present is what? 4. Are we there? So this implies that power of set B equals to 2 raised to power 4. And 2 raised to power 4 is 16. Are we there? Now, if I now ask you to list out the elements or the possible subset that you can form with this set B, just like the one I did for set A, then these are the elements you can form. Power of set B, the subset element is, the first thing is an empty set. The last thing is the complete set B. Are we there? So in between an empty set to the complete set B, you can form different subsets, like set with one element P, one element Q, one element R, one element S. I hope for each and every one element is well clear to you. Let me hear your feedback.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
On to another subset with 2 elements this time. So you have to join 2 elements without repetition. So 2 elements can come in PQ, PR, PS. Are we there? QR, QS. Are we there? RS. These are the possible 2 elements that you can form with this set. Are you well clear with this? Are we well clear?
Yes, sir. Yes, sir.
Yes, sir.
There
Sir,
are no
I have
repetitions.
a question.
Is that clear?
Hello?
There are repetitions. So the next set that you can form under this one that you won't exceed this set is the set with elements of 3. And the set with elements of 3, you can have PQR, we have PRS, we have QRS. Are we there? So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then the 15 can now give you that's P. No, we have PQR, PRS, we have QRS. Then there is one PQS, because I told you there won't be repetition. So this is the 15. Then the last element, which is the subset of this set that you can form, is the complete, which is PQRS. Now, if you look at the order of my arrangement, I start with a set with empty elements. I move on with sets that can be formed under this with one element. I move on with set that can be formed under this man with three elements. Then lastly, the set under this man with the complete element. So if you count the number of subsets here, these are the possible subsets, then you have it to be what? 16. That gives you the power of a set in your question. Is this part well clear?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
let me
Yes,
give
sir.
you an idea. Positemi will never ask you to list out this subset. I only listed it out so that you can have an idea of what power of a set is. Is that clear?
Yes,
Yes,
sir.
sir. Yes, sir.
Now,
Thanks,
Yes,
sir.
sir.
Now, bringing ourselves back to our class now. I've been able to tell you the type of set, the operations in set. Now, let us now go over our past question and bring out 1 or 2 questions where you will be using the idea of what we've done today in class to buttress our point on set theory. Shall we proceed? Do you have your past
Yes, sir.
question?
Yes, sir.
Okay. So let's start with our first question. First question. Okay, open your past question with me. Okay, this is not a question. It's not a question. Okay, open up to page 17. Page 17 of your past question. If you have the past question with me, open up to page 17 of the past question. Question 20. Question 20. Page 17 of the past question. Question 20. Are we together, class? Are we together?
Yes,
Yes,
sir.
sir.
Now, the question reads that in a science class of 42 students, do you have that? Do you have
Yes,
that
sir.
with me?
Yes, sir.
Yes,
Okay.
sir.
In a science class of 42 students. Now, you guys should follow me with the way I am going to solve this first question. That is how I want you to solve anything relating to set theory. Is that clear? Now, the question says, in a science class of 42 students. Now, the science class contains 42 students. So, science class contains 42 students. Are we there? Now, they said each student offered at least one of mathematics and physics. So that tells you that what? The science class is your universal set. What did I say just now? The science class is your universal set. Now, each student offers at least math or physics. These are the 2 sets we are talking about. Now, if 22 students offer physics, 22 students offer physics. Are we there? And 28 students offers mathematics. Are we there? How many students offer physics only? Physics only. Now, let me introduce you to how you can solve questions like this. I believe we had the question.
Yes,
You
sir.
get of your Venn diagram. Now, I will advise you, open your eyes clearly. Venn diagram. This man is my Venn diagram. Universal set equals to 42. This is the first set A. This is the first set B. I have math students equals to 28 students. Physics students equals to 22 students. If you can see the board, you can see where I put my labeling. The math 28 is outside, not inside the circle. The physics 22 is outside, not inside the circle. I believe this diagram is visible enough.
Yes, sir.
I believe the diagram is visible enough.
Yes, sir.
Yes, sir. Yes, sir.
Now, let's now go with what we need to do. We don't know the number of students that offer math and physics. So we call the number of students that offer math and physics X. Are we there? Are we there?
Yes,
Before
sir.
you a set question, you need 2 things. You need the universal set or the intersection of sets. Universal set or the intersection of sets. Without these 2 things, your set is not complete. That is why I introduced an unknown value X into this expression here. Is that clear? Now, having known that the value of combined value of math and physics is X, definitely the number of students that offer math only is this part here. So the number of students that offer math only is the difference between 28 and X. Why? The number of students that offer math is this whole circle. Are we there? The number that offer just combination of math and physics is this small circle here. Are we there? The number that offer physics only is this circle here. Are we there? Now, for this part here, it is 28 minus X. This part is called math only. For this part here, it is called 22 minus S. This part is called physics only. I hope I've made myself clear with the labeling. Now, we cannot say that the addition of everything here equals to your universal set. That is, universal set 42 equals to 28 minus x plus 22 minus x equals to 42. Now, 42 equals to, collect like 10. This cancel this one. 28 plus 22. That is 50 x. Then collect like terms again. 42 minus 50 equals to minus x. When you subtract this one, we have minus 8 equals to minus x. Subtract, take away the minus, therefore x equals to 8. Now, that is not the answer to our question. That is not the answer to our question. The question is asking us, what is the number of students that offer physics only? Then you cannot bring out a new diagram here that says math and physics. So the number of students that offer X, math and physics. So here we can say that the universal set is still 42. So here we have physics and we have math. The number that offer both subjects is 8. Now, if you subtract 8 from 28, you are left with 20. If you subtract 8 from 22, then you'll be left with that's
14.
14. Now, if you add 20 plus 8 plus 14, then you will have your 42 as your final answer. That tells you that what? Your solution is correct. Now, the answer to the question is now P only. And what's the value of P only, everyone?
14.
14.
14.
Not clear with my solution.
Yes, sir.
The board, not seeing the board.
Anyone with question?
Out.
I can hear you. Your question.
Sir, I have a question, sir.
You don't have a question?
I have a question, sir.
Okay, what's your question?
Sir, yeah, you wrote 42 minus 50. Is that 2 minus or just 1?
Just 1 minus. 42 minus 50.
Okay.
So 42 minus 50 is minus 8. Is that clear?
Okay, sir.
Like 10, you make sure that the number standing on that side remains the same. Then any number you are bringing into that side will be in front of it. That is why we have 42 minus 50.
Okay, sir.
Any other question?
Sorry, sir.
Any-
Sir. Sorry,
Okay.
sir. Sir, please, can you re-explain it? Because I had like a connection issue. That's the reason why, sir.
Okay, I should re-explain the same question.
Yes, sir.
Okay, now the question asks us, the question is telling us that in a science class of 42 students, 28 students offer math, 22 students offer physics. Now, how many number of students will offer physics only? Now, for you to break down this question, you can use a graphical representation like Venn diagram, or you use the theoretical representation, which is the formula aspect. Now, the Venn diagram is very visible for you. Now, Venn diagram says we have the universal set, housing math and physics. Now, The math, 28 students offering math is labeled outside. 22 students offering physics is labeled outside. Now, we need to know the number of students that offer both subjects first. That is why its name is what? X. Now, subtract this X from 28. You know the number of students that offer math only. Subtract this X from physics. You know the number of students that offer physics only. Now, how can we solve for X and use that same value to get for physics only? That is where I brought the mathematics out here. So doing the mathematics with the operators we have here, we end up having X to be 8. Now you substitute the value of X equals 8 back into this first expression, then that gives us the new diagram we have under here to be 28 minus X, 20, 22 minus X, 14. Then X remains 8. So if I add all these three together, I must get my universal set. That is just the logic behind it. Is that clear?
Yes, sir.
Okay. So I can proceed to the next question.
Yes, sir. Yes, sir.
Okay. So to the past question again. So let's see. Oh no. Okay, open up to page 105. Page 105. Page 105. Question 20. Page 105, question 20. Are we together? Page 105, question 20. 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 Now, so can I proceed? It says
Yes,
in the
sir.
Department of Accounting. In the Department of Accounting. So we have Department of Accounting. A class of 72 students. A class of 72 students is given. Each student offered at least one of economics and government. So that tells you that what the Department of Accounting is your universal set. So I give it another symbol. Another symbol, universal set. So they said that what? Each student offered at least one of economics and government. So I have economics unknown, government unknown. If 50 students offer economics, 50 students offered economics, and 32 students offer government, 32 students offer government. How many students offer only economics? The same question as the previous one. How many students offer only economics? Class, I believe you have the idea of this question. You can solve this question even without me solving it. Is that clear? So we are going with the same process, same method, same logic. So we start. We start with the diagram. Universal set equals to 72. We have economics. We have government. Economics 50. Government is 32. Now, we don't know the number of students offering both subjects, so I call it Y. So here is 50 minus Y. Here is 32 minus Y. So we start. Bring the mathematics outside. So that means 72 equals to addition of everything in the bracket there. Plus Y plus 32 minus Y. 72 equals to, this cancel this, I have 82. 82 minus Y. So collect like terms, 72 minus 82 equals to minus Y. Here is minus 10 equals minus Y. Take away the minus from both sides, then therefore Y equals to 10. Now, if our Y is 10, and they're asking us to find economics only. So what do you think our answer will be? Universal is 72. Economics and government. Economics and government. The common term is 10. So that means here becomes 50 minus 10 is 40 and 32 minus 10 is 22. So class, from the diagram, what is our answer for the number of children that offer economics only?
40.
40.
40 is correct. 40 is correct. 40 is correct. I hope it is well clear to everyone.
Yes, sir.
Well clear.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Do we have any questions?
No, sir.
Sir, yes, sir. Sir, I have a question, sir.
Your question.
Sir, we can also use X instead of using Y, right?
Yes, you can use any alphabet. Any alphabet. Any alphabet.
Okay, sir. Okay, sir.
Okay.
Okay,
What
sir.
is my first question again? Let's look for one more question. So yeah. First question. No. Okay, I've seen another one. Page 107. 107. Page 107. Question 9. Page 107, question 9. Are we there? Page 107, question 9. Page 107, question 9. Page 107, question 9. Page